Hey guys, welcome to day 23, and today we are going to be doing a bit of a review, and we're going to use everything that we've talked about in the last, 23 days and put them to work. We are making tic-tac-toe. And so how are we doing this? Well, we have to implement NetBeans. We have to open NetBeans. Implementation. Okay. And so, of course, what do? We go to File. We go New Project. We create so many projects here. And we are going to create a tic-tac-toe application. And so make sure you call it application. And basically, it's going to be a program where you can play tic-tac-toe as many times as you want, which is great. Save it up wherever you want, per usual. And we are going to be doing something a little different. We are actually going to make a class that represents the logic of our tic-tac-toe, and then in our tic-tac-toe application class, we are actually going to run the games of tic-tac-toe. And then we're also going to have a class for our AI, and so that's going to be the computer we're playing. And so here we go. We are going to open our source packages, and we're going to skip this application thing for now, and we are just going to implement the logic of tic-tac-toe. So here I'm opening up a new class, and we're going to just call this class tic-tac-toe, and we're going to open it here. And so when we are creating a class for tic-tac-toe, we have to think, what does a game of tic-tac-toe have? Well, it's going to have a board. So we're going to do protected char board. And so it's going to be a board of characters, like I'm the X's, you're the O's, and you're going to be clicking buttons. Then what else? Well, we're going to need a marker. If I'm the X's, you're the O's, that would be cool if we could get the user to decide that. And so we can do protected char, and we could call this user marker, because it's going to be the marker that we're going to say, okay, the user has placed an X here, and X is their marker, so we're going to put an X in there. And then again, we're going to do one for our AI as well. So this is like the computer. And so you as a person are playing against the computer algorithm that we're going to create that's just going to pick random available slots. And so what else do we need? We need a winner. So we're going to do protected char winner. And then we're also going to have a current marker. And so we'll do protected char current marker. And this will be whose turn is it type of thing. And so what do we want this to look like? And so I was nifty and I made up this cool comments thing. And I can explain what we're going to do. So inside of the storage of our char board, we are going to have the 0th index will be this position, the 1 will be this position, and we're just doing a linear array with 9 slots. And so whatever character is in the 0 slot, that's being in this portion of tic-tac-toe, etc. But we're going to make it look, we're going to do an abstraction and make it look like to the user that this is the way it works, that you click, you press 1 if you want to go to the 1 slot, you press 5 if you want to put your marker in the 5th slot. But it's not, I don't know. This to me is not very appealing to the user, and it kind of reveals some of the implementation, whereas just by adding 1, it makes it look a lot cooler. And so that's what we're doing. And the UI of our game is just going to be, it's going to be print statements inside of the console, and we are going to initialize it with everything's going to be this dash mark. And then when we play the game, we are going to enter the X's and O's, whatever the user marker or the AI marker is, into these slots. And these 0s and X's will be stored inside of our array, and then we'll just print it out in this special way. And we will learn how to do this. And so the first thing we need to do now is create a constructor. And so to do this, we are going to write public tic-tac-toe, because that's the name of our class. We're going to have a char player token. So what is the player's token? Is it X's? Is it O's? And then we're also going to have a token for the AI. And so we'll say AI marker as well. And then inside of here, we're just going to set this up. We are going to say the user marker is going to be the player token, and then the AI marker is going to be the AI marker that we passed as a parameter. And then we also need to make sure that the winner is set to this little dash character here, because there is no winner yet if we just started a game, and we need to add this here. So this doesn't freak out. We could add this here because we're talking about this instance. And so a little bit, again, review instance versus class. A class is the blueprint, and when we create different instances of our, game, each game is going to have a different winner, a different user token, a different AI token, and they're going to be played out differently. And so when we start a new game, that's when we create a new instance of our tic-tac-toe, game. We want the winner to be 0, and we want to set up our customized game here. just a bit of review, and these properties say every game is going to have a board, a user marker, an AI marker, but they may not have the same value. They could, but they don't have to because they're not static. And so here we also need to set up the board. And so we are going to say this.board, and we're going to create a function that is setBoard, and that's going to set up our board for us. And so we can actually create this function right now. We will do public char setBoard, open close parentheses, open close curly bracket, and inside of this we are going to say this char board equals new char with 9 slots, and then for int I equals 0 all the way up to I board.length, which here is 9, and then I++. We're going to do this 9 times, this loop, and we are just going to set every single entry to this little dash here because nothing has been entered yet, kind of like we did our winner. And then at the very end, we are going to return this board. And so because we can return this board and nothing like inside of our instance, like we didn't use our user marker or our AR marker or our board marker, we didn't use any of that inside of this function, then we can actually make this static. So we can say, oh, this is going to return a blank board, and anyone can use it, but it's going to be a blank tic-tac-toe board because it's in the tic-tac-toe class. Next method, public Boolean play turn. And so basically the Boolean part is that it's going to return true if we were able to play the turn, and it's going to return false if we were not able to play the turn. And so inside of this, we are going to write int spot, and this is the spot that the user wants to play. The user wants to put X there or Y there or whatever, their token, but we have to make sure that it's a valid, spot, and that it's not, outside of the range. And so we're going to create this Boolean that's called isValid. And with this Boolean, we are going to check if the spot is within range, and it needs to be available. And so we are also going to create a function that's isSpotTaken, and we want it to not be taken if we're going to make it valid. And so we will also enter the spot there. And these methods aren't created yet, so we're going to get errors. If the spot is valid, then we want to go board spot -1, and we want to put our current marker inside of it. And so the reason we're doing spot -1 is going back to our little comment diagram up here. The user thinks we're entering in spot 1, but really we're going to store it in spot 0 and then later print it out to look like this. And so if our player wants to go into spot 1, we really need to store it in spot 0. This may be a little confusing, but again, the hidden abstraction makes it look so much cooler. So of course you want that. Now, if it is valid, then we're actually going to play the turn. So we need to flip. If it's like the user's turn now, then we need to flip it over to the AI turn. And if it's the AI turn, then we need to, change it to the user's turn if, after they've taken their turn. So we'll say current marker equal, that's not how you spell marker equals current marker equals user marker question mark AI marker semicolon user marker. This is an if statement in one line. This is going to be a little weird, and basically what we do is we put our condition in the middle, and then we have this syntactic question mark, and we say if the current marker is equal to the user marker, then make this current marker the AI marker. Otherwise, if the current marker is not the user marker, then we know as, the programmers, that it must be the AI marker because those are the only two choices, and so we want to make our current marker the user marker. We want to flip the turn. Then once all of this is done, we will return isValid. And so basically the reason we're returning this Boolean is that if it was valid, then we played the turn. Otherwise, we'll return false and we'll say, try again, make another turn. This will make more sense when we implement in our application interface. And so moving on to our next methods, we are actually going to implement within range and isSpotTaken. For within range, we are going to say check if our spot is in range. And inside of here, we're going to do public Boolean within range, and inside here we're going to do an int number, which is going to be our spot, and we are going to say return if the number is greater than 0 and if the number is less than board.length plus 1. So here our number has to be greater than 0, so it has to be from 1 to all the way up to board.length plus 1 And here our length is 9, and so plus 1 would be 10, so it has to be between 1 and 9. And that's perfect because those are the slots that we set up there. Cool. Now we have to implement is spot taken. So we'll do check if the spot is taken. And here we'll go public Boolean is spot taken. And we'll insert the int number again, and we will actually do this in one line as well. We will return board spot -1 equals, and then have this character, the dash. And so actually we will make this a not, and this is not a spot, this is a number. And there we go. So basically we're saying we'll go and get the thing that was at this number spot. And so say we're given the number 5, we'll go check and see in storage if there's something at 4. So our user wants to put something at 5, but the 5th thing is stored at index 4. So if there's something at 4, then it's not going to equal this dash here. Basically, if that spot does not equal this dash character, then that means it's taken. And so if the spot is not taken, then the false will return here, and with our not, that'll return true, and if it's within range, this will return true. So if it's within the range and it's not taken, then it's a valid choice for our person to put in. Now we are actually going to create a function that will print out the board, and so we are going to do public void print board, and with those, parentheses and curly brackets, we are trying to create this thing. And so if I copy and paste this, and we can put it down here, this is what we want to print out for the user. And so if I tab these over, this is what we want to do for our user here. Here we are. Okay, so how do we print this out? Well, first we're going to print out a new line so everything's nice and pretty, and we just do that print line there, and then we're also going to loop over everything that's in the board. So our I will start off at 0, and then we'll go all the way up to board.length, and then we'll increment I right there. And there we go. And so inside of here, we're going to say if I is mod 3 equals 0. And so if I is a multiple of 3 and I does not equal 0, because we obviously don't want to do it at this condition, we only want to do it like when we're going here and when we're going here, like after, when we're at the third, spot, then we want to print this before we print out the third spot. That's what that thing is. But yeah. And so if this is true, then we want a system.out.println another line so it's not right up against it. And then we're going to system.out.println, and then we're going to do just a series of dashes here. And we'll actually do the same amount of dashes that we have here, so it's all equal and lined up. There we go. And then after this, once we print out our lines, then we want to do system.out.print, and we're going to print this little dash thing, and then we're also going to print whatever is at the board I. So whatever it is, if it's a character X or Z or whatever, that is where we would print it. And then we will print out another line to make it, again, all nice and tidied there. And so that's great. Now we have a way to print the board. Now we also might want to show the user how to input their data. So up here we have this little 1, 2, 3. We want to show this is how we want the user to input their X's, their O's, how we want to say this is how you're showing which slot you want to put your X or O into. And so we're going to create another function that's going to be called public void print index board, and it's not going to take anything. And we're actually going to copy this code. I know copying code is bad, but here it's just the easiest way to do this. And so instead of saying board at I, we are just going to do I plus 1 because our I is starting off at 0 and we're going all the way to the board.length. And so here we'll just add 1. And that's really what we want the user to think that they're doing. Again, adding a level of abstraction. And so once you've done that, that's it for that method. And we are going to create another method that is going to use a lot of helper methods. And so we are going to write public Boolean, is there a winner? And this is going to check if there's a winner on the board. So if we have 3 X's in a row, 3 O's in a row, making sure if that is the case, then we are going to say there's a winner out there in the world. And so we are going to use a lot of helper functions for this. And so we're going to create 3 Booleans. We're going to say Boolean diagonals and middles. And so we will say if the right diagonal or the left diagonal is all the same, or the middle row is all the same, or the second column is all the same, and the thing at slot 4 is not equal to this dash here, then this is going to be true. So what we're doing here is if like the right diagonal is all x's, if the left diagonal is all x's, if the middle row is all like x's, if the second column is all x's, then we want this to return true. But we also want to make sure that we're not just saying automatically true from the very beginning, so we need to check that the thing that all of these three have in common is not null, which is like this thing here. And so we will implement these later, but let's just finish is there a winner first, and then we will go back and get those later. And so for our next big Boolean, we're going to say Boolean top and first, which is going to check the top in the first column. And so we will say top row and then semicolons, or first column, and it's checking if those like match up. And what do these two have in common? Well, it's the board at index 0, so we'll make sure that is not equal to null, or else it's already like trivially true when we first start. And then we'll have our last Boolean, which is going to be bottom and third column. And here we are going to check the bottom row or the third column if either of those are the same and the thing they share, which is the board at 8, is not equal to this little dash here. So now we have these three, pretty hefty Booleans. And so we are going to check if the diagonals and middles, if like we have a winner there, then that means the winner is in board at position 4. And so the thing that all 4 of these like conditions have in common is that no matter what the thing at like the center 4, no matter what it is, it's going to be that same character for all of the checking conditions. This might take a while to like think about and understand, but I promise it will once you kind of latch onto the idea. So the diagonals, like the right diagonal, the left diagonal, the middle row, and the middle column, they all share that middle spot, which is 4. So no matter which of those conditions are true, the winner is going to be at spot 4. And this is the same type of ideology that we're going to use for the rest of it. So we're going to say if the top and first, if we have a winner there, and true means a winner, we're going to say this dot winner is in board 8, because again, it's what the top and first share. And it's not going to be board 8, it's going to be 0, because that's actually what they share. And then we'll say if, and we misspelled something here with the S. Okay, otherwise we need to check if the bottom and third is true, and if it is true, then that means the thing that they share is at slot 8, and so we need to say this dot winner equals board 8. There we go. Otherwise, nothing, is true, and so we don't really need an else, and we will actually return diagonals and middles, or top and first, or bottom and third. And I probably spelled diagonals wrong. Yep, there's an A. Okay, so what this is doing is if any 3 of these are true, then we have a winner. So we want to return true. And we've already saved the winner at that correct, wherever that position was, we've saved that that character is the winner, so we don't need to do anything else there. So what is this saying? If there's a winner, we need to check, all of the possible combinations that there could be to be a winner. And if any of those are true, then we do have a winner and we've saved the winner. Otherwise, we do not have a winner, so all 3 of these should be false. And the winner can't be this null character here, which is why we have these conditions here. Now we need to implement all of these helper functions. And so the first one is public Boolean top row, and here we're going to check if, and we're going to return this thing that we're checking, and we're going to say if the board at 0 is the same thing at the board at 1, meaning slots 0 and 1 are the same thing, and that thing is also equal to the thing at slot 2, then we do have a winner, and so this should return true. And this is again the type of logic that we're going to be doing for everything else. And so now we'll have this middle row function that's going to check the return board at 3 equals the board at 4. Again, this is going to be what we're doing for all of these. And so we have the board at 4 equals the board at 5. So if that second row, if the things at slots 3, 4, and 5 are the same, then this should return true. And then of course we'll have our bottom row here, and that's going to return the board at 6, which should equal the board at 7, and the board at 7 should equal the board at 8. There we go. And then for some more helper functions, we'll do, and notice how these are now starting to not be read. And so we'll do Boolean for the first column here, And for the first column, we'll have to return the board at 0. And we'll have to make sure that's equal to the thing that's at slot 3. And the thing that's at slot 3 should be equal to the thing that's at slot 6. And later on, we check if that thing is null. And so we'll also have one for the second column, which is going to be return board at 1 if that thing is equal to the thing at board 4 and the thing at board 4 is equal to the thing at board 7, then we do have a match and we have a winner. Then public Boolean, the third column, we will return the thing at board 2 if the fact it is equal to the thing at board 5, and if the thing at board 5 is equal to the thing at board 8. And then we'll have, again, another function. We'll have to check the right diagonal, so we'll do right die, and we'll return the board. We'll return the board at 0, and if that is equal to the thing at 4, and the thing at slot 4 is equal to the thing at board 8. This is a lot of typing, I know. We will get to the end of it soon. Now we're going to also create one for the left diagonal, so we'll call this left die, and we'll return the board. We'll check if the board at 2 is equal to the board at 4, and we also will need to check if the board at 4 is equal to the board. And if both of those are true, then we have a winner due to the fact that they caught the condition. And for this third row up here, we should have called it column, and then we also need to add some curl, we need to add some parentheses to our left eye, and now everything should work out great. And so we have 2 more functions left to complete the logic of our tic-tac-toe. And so one, we need to check if the board is filled, and so we do public Boolean is the board filled. And inside of this, we will go through each thing. So we'll have a for loop. We'll check each slot in the board, and we'll go up to the board.length, and we will be checking, and that is that thing, and then we'll do I++. And so if the board at that slot is equal to the dash thing, then we want to return false because that means the board is not filled. And if we go through all the slots and we haven't returned false, then we will eventually return true. And then we finally have a last thing that is going to return a string, and it's going to tell us if the game is over. So we have this function called game over. So we're going to have a Boolean in here that's going to be called did someone win, and we are going to make this is there a winner. And so basically, did someone win is like, we'll go and check, is there a winner based on all of the conditions that we just created? And if there is, then did someone win will be true. And so if did someone win is true, then this if clause will be executed. And if there's a winner, we will return we have a winner, and then we will say the winner is, and then we will add this dot winner. So we can have that char there. And inside of here, we will say the S as well. And so we'll say, we have a winner. The winner is A's, and then we'll add an apostrophe here to make it all pretty as well. And then otherwise, we should check if is the board filled, because that means there's a draw. If there's a build, if the board is filled and no one can make another choice. And so we will want to return draw, game over. So we'll say the game is over. And then otherwise, if none of these are true, then we will return not over because the game is not over. So we'll say not over. Here we are. We'll add that semicolon as always. We'll save this. And now we are actually going to implement our tic-tac-toe application. We're actually going to implement the stuff that's going to make this thing run. And so we will take that away. And of course, the first thing that we need to do is we need to create a scanner to scan for some input. So I need to be able to just type, A or B as my character, and I'll be able to interact with this program. And so to do that, we create a new scanner SC, which is going to be a new scanner. And we're going to take the stuff that we input into the system. And so we have system.in. And then we're going to add an import for our scanner here. And inside of this, we're going to create a Boolean that allows for continuous games. Here, we're going to create this Boolean. It's going to be called, do you want to play? And so do you want to build a snowman? Do you want to play this game. And so we're going to say, while you want to still play, while you still want to, build the snowman, we are going to actually play the game. And so the first thing, we're going to print out this like welcome message that's like, hi, welcome to Tic Tac Toe. This is how you play. And so we're going to system.out.println, and we are going to say, welcome to Tic Tac Toe. You are about to go against the master of Tic Tac Toe, which is our AI, which is not going to be a master. It's just going to choose a random slot, but we're confident we're going to pretend we're the master of Tic Tac Toe. Are you ready? I hope so. And then we'll add a little exclamation point. And then we're going to do \n so we can add a new line here so it's not extending on forever inside of our console. It's formatting stuff. Just do the \n to get that going for us. And so we're going to say also, but first, you must pick what character you want to be and which character I will be. So here it is. Welcome to Tic Tac Toe. You are about to go against the master of Tic Tac Toe. Are you ready? I hope so. But first, you must pick which character you want to be and which character I will be. And so here we are. We are going to do another system.out.println, and we're going to do this inside of our while. Everything's going to be inside this while here, basically. And we're going to print out another line, and then we are going to print out, enter a single character that will represent you on the board. And so this character, whether it's X's, O's, B's, apostrophes, whatever it is, it's going to represent you. And so how are we going to get this character? Well, we're going to create a variable that is a char, and we're going to call it player token. And it's going to be the sc.next. So get the next thing that you get from the scanner, but only take the character that's at index 0. So our, person could enter Taylor Swift, but we're only going to take the T because that's going to be the token that represents them in the game. We are going to print out another print line, and we are going to say, enter a single character that will represent your opponent on the board. Opponents on the board. And so we will say our char opponent character token here is again going to be sc.next char at 0. So again, your opponent could be Nicki Minaj, but you're only going to get n because this is only going to take the first character. And we're going to have an error here because I entered a 0 here, and that should not have been there. And of course, we have to create a new instance of our Tic Tac Toe to play the game. So we're going to say Tic Tac Toe is going to be a game, and we are going to create a new Tic Tac Toe instance. And of course, it takes, if we go back to our constructor here, that is at the very top of this very long class, or well, long for us. Our constructor takes a player token and then an AI marker. And so our player token will just be player token, and then our opponent token will be our AI marker here. We got to add that semicolon. And we are also going to create a new AI character, and that will represent our AI in the game. And so we haven't created this yet, and so we are going to actually create an AI class right now. And it's going to be a very simple thing. We are just going to have one method, and so it's not a huge class, just one method. And we don't actually have to create a constructor to create instances, but just nothing, like we're not overriding the constructor method like we did in our tic-tac-toe, game. We're not going to be, this is not going to have any fields, but again, if you wanted to expand on your AI, this would be the place to do it. And so in here, you're going to do public int pick spot. And so the only thing that the AI, the computer player, is going to do is pick a random location. And so the first thing we have to put in is the tic-tac-toe game. And so it has to know what game it's playing, what slots are still available, stuff like that. And so now we are going to create a new array list of integers, and it's going to be the available choices that we have. And so we're going to create a new array list with our, knowledge. And of course, this is going to be integer, and we need to import our array list. And then we are going to create a for loop that's going to go through all of the things inside, through all of the slots inside of our board. So this will go from I0 to 9, we'll increment I. And we are going to say, okay, if it's available, we'll add it to our choices array, so then the AI can actually choose it and pick it randomly. And so here we will say, if the slot is not taken, add it as a choice. And we'll say, yeah, we did choices there. So then we can have multiple choices. And so we will say if game.board at slot I is equal to this little dash here, meaning nothing is in this, slot I, then we want to add this index to our choices. So we'll do choices.add I plus 1. And why are we doing I plus 1? Well, we're expecting something between 1 and 9. So if we have 0 and 0 is, the thing at slot 0 is the only thing available on the board, we want to increment it to slot 1 because that's how the user sees it, and that's how we want the AI to see it as well. The abstraction is going to be to the AI as well. The AI won't really know how the game is implemented or even how it's played. But again, you could change that if you want to create a stronger computer player that's a little bit smarter than the one we are going to create. And so now we have all of these choices inside of our array list. And so we are actually going to create a random here. It's going to be random, R-A-N-D, and we'll do new random. And it's going to, this pick spot is going to choose a random available spot and say, that's where I want my token to go, because that's what our AI does. And so we have this random thing, and we are going to say our int choice, meaning the spot that our AI is going to choose, it is going to be choices.get, meaning we're going to get the choice that's at this index that we're going to calculate right now. And this index that we are going to get is going to be math.abs ran.nextInt. We've done this before. And then we're going to mod it with choices.size. So basically what this says is pick a random index between 0 and the amount of choices we have, and then go get that choice. And so randomly pick a choice from the available choices that I've calculated from before. And then we're just going to return this choice that we come up with. And because we already accounted for the fact that we want to be choosing something between 1 and 9, we can just return the choice. And that's it for our AI. So going back to our tic-tac-toe application, we are going to code the really, really fun part. And so now we will actually set up the game. And this is kind of really claustrophobic right now. So I'm going to add some space here. And we'll say getting inputs as a comment there. So this is setting up our tokens and AI. And now we're actually going to show the user how to play. And so to do this, we are actually going to print out the index board that we created from before. That's going to say, okay, you're going to enter 1, 2, 3, 4, all the way up to 9 to actually put in your slot. And so we're going to have tic-tac-toe dots, and we're going to say print index board. And we can actually go back and make that function static, because we're not, board.length could very easily be 9 because we know that every single board is going to have length 9. So we can actually make this static and not even access our thing. And then we need to add those parentheses, but then we're all good. And so we're printing out, this is how you're going to play the game. And before that, we actually need to say, okay, this is how we're doing it. So we'll need to do system out .println, create a new line, and then we'll system.out.println, and we're going to print out the statement. Now we can start the game. So now that we have our characters in place, we have our player token, our opponent token, we are going to start the game. And so to play, enter a number, and your token shall be put in its place. And then we'll again do the dash in so we can get a new line and make it, a little bit more formatted. And so that's the same thing as doing, instead of doing print, we'll do println. That's this dash in adds a new line. And so it's not all claustrophobic, and we don't have to set this into multiple, print statements. We can say, I want this whole string to be printed, but I want break lines inside of it. So after our in, we'll say the numbers go from 1 to 9, left to right, then we shall see who will win this round. And so now we can start the game. To play, enter a number and your token shall be put in its place. The numbers go from 1 to 9, left to right. We shall see, and we should probably be instead of we shall see who will win this round. Then we'll print the index board so it kind of makes sense what we're talking about. And then after that, we will also system.out.println, another line so it's pretty, and then we'll say let's play. And then we'll say while the game is not over, so game.gameover.equals not over. So while the game is not over, then we're going to do a bunch of code in here. We're going to let each player take its turn until the game is over. And so we will do if the game current marker equals the user game.user marker, then that means it's the user's turn. So we're going to say user turn, and then we're going to system.out.println it's your turn. There we go. And we will say enter a spot, and we could actually say enter a spot for your token. And so we will say the spot is going to be the next integer that the person inputs, and so it could be 9, it could be 10, it could be any number, and then later on we're going to check to make sure that's right, and if it's not right, then we'll say, okay, you need to enter something else because the other thing wasn't valid. That's why we had our play turn return a Boolean, so we could have this type of thing. And so we'll say while game.playTurn spot. And so if we were able to play the turn, then this would return true. So while we cannot play the turn, then we want to system.out.println try again plus spot plus is invalid. This spot is already taken or it is out of range. So basically we're saying it's an invalid spot, so enter something else, and we can do spot equals sc.nextInt. And so by resetting spot, we allow this while loop to break or to keep going depending on what the user inputs next. Then once we're out of this while loop, we'll say system.out.println you picked, and then we'll put the spot that they picked. So they feel like the computer did what it was supposed to do, and that if they thought they put in something else, that the computer, didn't match up what spot their token went into and what they entered, they'll say, oh, I picked this spot and I thought I picked the other spot, but of course the computer's telling me like 3 times I actually picked this spot, so that means I must have accidentally done that and lost my game. If our current marker was not the user marker, then it must have been the AI marker, so then it is the AI turn. And so we'll system.out.println it's my turn, meaning the computer is saying it's my turn. And we will have the computer pick out its spot, the AI pick spot. And so we will say int AI spot equals AI.pick spot, and we'll enter the current game that we have right now. So when we do this in our AI class, this function that we just created will be run, and it will return a valid spot that we can, put in. And we won't have to do this whole play turn thing because we know that the computer is only going to come up with a slot between 1 and 9, and the whole algorithm that we created here is based on the fact that the spot cannot be taken. So we know that the AI is never going to choose an invalid spot. But if you do something else with your AI, you might want to use the functionality that we built in here with play turn and say, oh, AI, do something else. But that can increase the running time later on, which is bad. And so with the user, of course the user can spend all the time they want choosing which slot to choose and trying to go out of bounds or out of range or choosing like an invalid index, but we want our computer to be super fast because we as the user don't want to be waiting on the computer, but we'd wait on another person, right? Yeah, okay. And so once we pick our spot, we are actually going to have our AI play the turn. So we'll do game.playTurn with our AI spot, and it's going to know, the marker we know is going to be the AI marker because this if statement was not true. And then we will add another print statement that's system.out.println, and it says I picked, and then we'll input the spot that the AI picked, AI spots, and then add a little explanation point just for fun. And then we will have this else closed, and we will print out the current board, and so we'll say print out new board, and we will print out, what does the game look like now that I've taken my turn or the AI has taken their turn. So we'll say AI.print board, and we should probably print out a new line before that to make it all, gorgeous and everything. And so this loop will keep going, this while true loop. If the game is not over, either I will take my turn or the computer will take its turn, and those will go back and forth until there are either no slots available, someone wins, and yeah, those are the only 2 choices. Either there's a draw, there's no more slots left, or I won or the AI won. And so while the game's not over, we're taking our turns. Once their game is over, there are no more turns to take because someone won or there's no more slots left. And so we want a system.out.println, whatever the message that the game over, prompted to make. And so this will say, oh, it was a draw. Oh, it was X is 1, O is 1. That's what this game.gameOver will return because we did that inside of our tic-tac-toe. Then we will system.out.println a new line, and we will try to set up a new game. So this program is going to allow you to play as many games as you want in a row. And so we are going to do a little comment here, and we'll say set up a new game, ... or not, depending on the response. And so we will system.out.println, and we will say to the user, do you want to play again? Enter Y if you do, enter anything else if you are tired of me. And so we'll add a semicolon back there, hit enter here for formatting. And so we'll say, do you want to play again? Enter Y if you do. Otherwise, if you're tired of me, enter whatever you want and you will be rid of me. And so we'll do a char response. And again, we'll get our response from the user through the scanner, and we'll just say scanner.next, and we'll do .char at 0 because we only want the Y character. And we're going to say, do you want to play, which is what our first while loop was based off of up here. If you remember, we had this while loop that continued to keep playing a new game as long as it was true. And so we will say, if we want to start a new game, then the response needs to be equal to the character Y. And so we will just do that. So if the response is equal to the character Y, then we do want to play a new game. Otherwise, if anything else was entered, we do not want to play a new game. And so do you want to play will equal false. And then we'll print out a couple new lines just to make it formatted well. System.out.println. There we go. And we'll clean that up. And we have just created Tic-Tac-Toe. Isn't that incredible? Oh my God, we just created Tic-Tac-Toe. This is a game that you've probably played since you were little, but now you actually program something that will play this game for you. So when your cousin is bothering you about wanting to play Tic-Tac-Toe, you can be like, I made Tic-Tac-Toe. Like, play my game because I already made it inside of code. And so let's play our game to make sure everything works accordingly. And eventually you'll make tests to make sure it works. And so if this did not pop up, then you probably need to press this button up here. Notice how it changes, and you might actually need to pull this little thing as well. So here it says, welcome to Tic-Tac-Toe. You are about to go against the master of Tic-Tac-Toe. Are you ready? I hope so. But first, you must pick out which character you want to be and which I will be. And so I will say X's will represent me, and then O's will represent my opponent. And so here it is. It says we have a winner is dashes, which means we probably have an error somewhere in our tic-tac-toe. And of course, we're going to have some errors, and so I went and debugged a little bit because we all make mistakes and things. And so one thing that we forgot to do is that we forgot to set the current marker. So in the beginning, our current marker, this .current marker, should be our player. So we're going to let our player go first here. And so we're going to actually say this is the user token, the user marker. Here we are. And so we're going to set the user marker is going to be the current marker. And then we also need to add down here, I already added them, but you need to add these parentheses around the right, left, middle, and second column and inside of here so that it knows you should do that ORing first before you do the AND. Now if we run it, we will say I am an A, the opponent is a B, and now it's our turn. So we'll say 1 is the first spot we want to enter. And so if we actually pull this up here, we can actually see what's going on. First, I picked a character. I'm going to be A's. The opponent is going to be B's. I picked 1 as my first slot, so an A popped up there. And then the AI was like, it's my turn. I picked slot 3, and so they put their thing in here. So I'm going to choose slot 5 because according to this thing, that's where I should go. And so I picked 5, and so here I am at 5. Then the opponent chose slot 2, so they have a B there, and then I'm also going to choose A again, and A does not work, and so it errors. And so we are going to play again, and we will do this super quickly, and I'm just going to enter 1, and they picked 9, so they're there, and then we'll have 3, and then it's over here, B is there, and then I'm going to win with 2. And so there we go. And this is because I entered a debugging thing, but here we have a winner. The winner is A's, and then we can say if you want to play again, we can do Y, and there we go, we can play again. And so we can go X, O's, we can do 1, 2, and then we can do 9, and then we can do 7, and then we can do this middle one, which is 5, and so then I won again. And so there we are, you just created tic-tac-toe and it works. And so that's it for this video. The Hacker Rank Challenge is down below in the description, and if you have any questions, feel free to leave a comment on this video. I hope you learned something, and I will see you tomorrow.